다음으로 두 번째 해외 기술 발표가 있겠습니다. 이번 해외 기술 발표는 유니진의 CEO 겸 창립자인 데니스 쉐르긴님께서 해주시겠습니다. 데니스 쉐르긴 대표님은 세계 기업의 시뮬레이션 및 교육, VR 시스템, 디지털 트윈, GIS, 도시 계획 및 스마트시티에 사용하는 대규모, 대화식 시각화를 위한 독점적 실시간 3D 엔진을 개발하셨습니다. 또한 스마트시티 이니셔티브를 비롯한 VR 기술을 구현한 엔터프라이즈 프로젝트의 풍부한 경험을 보유하고 계십니다. 데니스 쉐르긴 대표님을 큰 박수로 맞이해 주시기 바랍니다.
Hello everyone, my name is Denis Shergin, I'm CEO of Unigine. We are a software development company, and today I will talk about high-quality real-time 3D visualization for digital twins being used in smart cities. So first of all, why would we need high-quality 3D visualization in the context of smart cities? Well, our world is three-dimensional, and we used to perceive information visually. So if you need to deliver some complex context for decision making, it is easier and more efficient to perceive it visually rather than seeing just numbers. Also, when dealing with some emergency situations in the city, most of the time it is a collaborative work of different agencies. And in order to save time, for example, if there is a situation room where you are trying to find a solution for this crisis, it is hard to communicate between teams because all of them has different jargon. While if you have a 3D model where you can visually show the proposed decision, it's way easier to come to an efficient solution. And high-quality visualization is important when you present your project or idea to top management or government officials because it is more compelling, it is easier to memorize, and it's way better than just dry numbers as well. But high-quality 3D visualization is in use not only, it's not only fancy images. If you have a detailed and accurate 3D model of the city, it enables you to run a lot of analytics-driven decisions. Like you can measure shadowing, you can measure line of sight, insulation, microclimate based on this 3D model analytics. Autonomous vehicles are a growing trend nowadays, and in order to learn the critical component of computer vision, virtual reality is in use nowadays. Because before putting an autonomous vehicle on a real road, it is better to verify that it is working correctly in a virtual environment. It is safer and faster. So correct copy of a city is in use to learn vehicles, autonomous vehicles these days. And we have also a customer who is engaged in flying vehicles because it is also the next trend. There will be flying taxis, and they also need computer vision algorithms to be trained how to operate in really dense urban area without collision avoidance and all of this. But in order to make a real-time 3D model of the city, there are a lot of technical challenges, and we learned them through 14 years of building our technology. So basically, one of them, there are a lot of 3D visualization technologies available on the market. Like there are game engines, which are fine, but they are not designed to deal with dense urban areas, because a regular game engine has some core limitations. For example, they cannot work with spaces larger than 10 by 10 kilometers in size when viewed from first-person perspective. This is a core limitation. Regular game engines assume that the Earth is flat and they operate in X, Y, Z coordinates, while it is not true. If we are working with urban visualization, the Earth is round, It operates in all the maps are coming in latitude, longitude, altitude coordinates, and the space can be virtual scene can be as large as the whole planet. So the technology must take all of this into the account. And by the way, starting from this slide, it's all of the images are captures from real-time applications powered by Unigine. So map projections is also an issue because, for example, this scene in virtual scene in California was built from different data sources, publicly available, some OpenStreetMap, digital elevation model data, and some of them are use different projection systems, and visual system need to match them together in order to avoid discrepancies. Speaking of data sources, there are hundreds of data formats and for GIS systems, and they have different nature of regions. For example, if we build a city in virtual reality, we have multiple data types. We have just digital elevation model plus satellite imagery for terrain. We have LiDAR scan data. We have drones capturing orthophoto, which is recognized by with photogrammetry algorithms. We have manually crafted 3D models of landmark buildings. We have BIM models being imported from specialized software. So all kinds of different formats being in use to recreate realistically looking and correct model of the city. And if we are talking about digital twin of the city, it's not only about displaying the geometry, where the object is, but also about multiple semantic attributes attached to every entity. So this 3D visualization software also need to take this into the account and provide clear API for access to these attributes. A modern city is ever-changing organism. So we have multiple real-time data layers like energy consumption, traffic, social media activity. It all changes every second. So the real-time 3D visualization need to update all the objects in the scene, rebuild it multiple times per second, while regularly 3D scenes are pretty much static in other applications. Also, if we have reasonable, realistic viewing distance, if we take a look at the dense urban area, we get tens of millions of polygons to visualize, and it is very demanding for modern GPUs, which are available on the market. So performance optimization is crucial in order to deliver dense environment, virtual environment. And you've seen already some examples today of 3D visualization, but what matters also is a visual fidelity and how realistic the representation is, because it needs to take into account lighting algorithms, correct vegetation rendering, and correct shadowing, and all of these factors need to be taken into account. So in terms of, we see a lot of informational systems related to the city which requires 3D visualization, like GIS, digital twins, BIM, and AI training sites for computer vision. And there is a lot of disconnected software, tools, and data services, while there is definitely a need for a unified visualization platform. And Unigine 2 can be one of the solutions, because it has all the technical challenges I've listed resolved already, and it is proven by several international smart city projects, and it is extendable. It has extendable architecture and available to other developers as SDK or as a kind of solution for end customers. I would like just to show you some cases powered by Unigine renderings. So, for example, this is a case from France. This is a regular architectural visualization, but it has very high quality in order to convince future property owners or investors to step into the project, and they can be inside of this project. It's not just an image, it is a dynamic interactive scene. They can walk around and feel themselves immersed into the house. Also, one more case from Australia where our customers are using Unigine to represent, to propose their architectural projects, and when they propose some new building, it is always for them embedded into the virtual copy of the city to give an architectural committee a good context and a good understanding how it will correspond with all of the existing environment. And this case is from China, and it gives you also an idea of how a person can see some planned environment which is not yet available in reality, but before experiencing it in reality, a person can immerse itself into this place and figure out how comfortable would it be. Would it be nice to sit here on a bench to enjoy the view? How it will look like in different time of the day? How it will look through different seasons? And that's all about the personal experience. And if we are talking about cities, cities are for people, and it is really important. This is another example of digital twin for oil refinery with a lot of live telemetry going on from IoT sensors, which can be also same complexity of systems can be used in cities to maintain different infrastructure, parts of the infrastructure. And this is another case from Moscow, which is one of the largest cases for us where Unigine is used. Basically, Moscow government is using Unigine-powered 3D visualization model for decision making, and they have a blend of different publicly available cloud data, plus their privately collected and refined data from drones and data collection vehicles driving Moscow streets. So they have a very accurate presentation of a geometry of the city, of different layers like energy, traffic, and economy factors. And all of these layers being visualized together gives and mayor and city officials a really great context when discussing some changes and some improvements in the city. Because what if we build a road here or there, or what would be the outcome of this renovation of some particular part of the city? So this is a kind of platform which gives them real-time decision platform for well-thought smart decisions. And this is kind of example of Unigine-powered application visualizing GIS data in real time, and it is generating data in real time as well without offline processing. So I believe that these are some cities. There should be a model in Seoul, and there should be a model in Daegu. And once you will add more data layers, it will be more and more detailed. So just with live connection to traffic data, lighting, and all of the and representing a real digital twin of a city with all its parameters. So what's next? As we discussed, technology at the moment is going ahead of social changes. in terms of smart city initiative. So a lot of we see that technological advances are faster than changes in people's minds, and what we hope that it will change soon. But from the technology standpoint, we see the transition that definitely through several steps ahead, there will be a transition to planet-scale systems, not only city scale but planet scale. And we see some sort of this initiative in Russia where they are talking about country scale, smart country systems, and it definitely should be extended further. Also, there will be a blend from professional VR experience used by city planners. It will transit into personal experience, personal AR experience for people on the street, with the same level of digitalization and with the same usefulness of the public services. Also, there will be more data because more and more data sensors are installed in the cities, and more and new types of sensors are getting introduced. But as it was mentioned, collecting data is not enough because we already talked with a lot of industrial companies who are facing the problem with big data. They've collected a lot of data of different nature, but now they do not understand what to do with it because data doesn't mean useful information. And in order to distill some useful parts from it, and in order to make some predictions based on this big data, there will be the rise for AI algorithms to deal with ever increasing amount of data coming from IoT. And definitely there will be some new standards for digital twins being used for smart cities. So thank you so much for your time. And our solution is already here, and the image quality I demonstrated is already a reality, so it can be deployed to some services in Daegu and other cities as well. Thank you.
네. Thank you for the presentation, Dr. Shilgil.